Hello and welcome everyone to another installment of the Big Data and AI webinar series. If this is your first time joining us, these webinars bring together industry experts to discuss strategies, solutions, and emerging technologies in the data and AI space. Our aim with these webinars are to educate and advance the industry. Today's webinar, we are joined by Chris Santiago, who is the Engineering Director of Unravel, and Christopher Klaus, who is the Solution Engineer at Talend. Unravel Data and Talend are sponsors for our upcoming conference on September 29th and 30th. The conference will be hosting 9 stages on the topics of big data, AI, cloud technologies, and cybersecurity. And we will be hosting this conference online as well as in person. For more information on the conference, please visit our website, bigdata-toronto.com, to learn more. Before we jump in, a few housekeeping notes. If you have any questions for our presenters, these questions will be addressed at the end of each presentation. Please use the Q&A tab to ask any questions and not the chat tab to ensure that we see your questions and they don't go amiss. Also, we won't be taking any breaks during the webinar. We'll be going straight through to the end, but this webinar is recorded. A link to the recording for the webinar will be sent to all participants and registrants tomorrow morning. If you missed any of our past webinars, if you visit our website, bigdata-toronto.com, and go to our webinar page, you'll actually see a full list of all the webinars we've put on in the past and any upcoming webinars that we have. So we are going to start things off today with our first speaker from Unravel Data, Chris Santiago.
Thanks, Kim. So giving you one second here, get us situated here. Can you guys, Kim, can you see me okay? And hear me?
You are good
More
to
importantly?
Go.
Awesome. Yeah. Thanks, folks. Thanks for the introduction there, Kim. So hi, folks. My name is Chris Santiago. I am the Director of Solutions Engineering over at a company called Unravel Data. A bit of a background before I go into the content. Unravel Data is an application performance management tool focused on the big data stack. So think of all the great stuff that other APM tools have done, like for example, like App Dynamics, New Relic. We aim and strive to do the same thing for big data applications, whether they be on-prem, in the cloud, or even hybrid. So in terms of history of myself, I've been in the big data space for a number of years. First started off my foray into big data as an application developer. So writing those MapReduce jobs, Spark applications, all that fun stuff. From there, I've moved on to managing Hadoop environments, and most recently my latest stints have been selling technology on the big data stack. So I've seen both sides of the fence as a user, and then also as an administrator. So I think the points I make, kind of resonate for both sides of the fence. Most recently at Unravel, we've been spending a lot of time helping customers drive them through the cloud journey, whether that may be hybrid environments, whether that be cloud, multi-cloud, maybe you're just starting in the cloud itself. I've been spending about the last year and a half, really focusing on those customer pain points to ultimately drive the best solution based on their architecture, the requirements, et cetera, and so forth. So that way they become successful. So larger customers, like in the thousands of nodes, down to your customers that might start their journey from within big data with maybe with Amazon or Microsoft. So I've helped all gamuts of customers. So we'll go through a couple of things here, but at the end of the day, what I'd like the audience, you guys, to really walk away with is have an end-to-end understanding of like, hey, what are the good stuff? What's the bad stuff? What things do I need to do so that way I can make an informed decision in which cloud environments and cloud services that I want to go through. Then we'll spend a couple of minutes here talking about a tried and tested approach, best practices per se, on hey, how can I get to the cloud and actually be successful, not just migrating to the cloud, but then ultimately having success and continued success with the cloud that you select. and ultimately just becoming wildly successful in the cloud architecture that you choose. All right, enough about me. Let's actually get into the content. So today, let me go ahead and switch off my camera here. I really wanted to talk about the impacts of big data in the multi-cloud environment. And so with my experience, I've had, well, the experience to see a lot of good things, a lot of good decisions, and I've also seen things where, I've seen some cloud initiatives fail. And so I like to level set here because with this, it's to kind of give a lay of the land on some stuff that I think would be useful for you guys when you make your decision. And so first one here, we'll be talking about is best practices for ensuring cloud success. And so on the number of customers that have, very, very successful cloud deployments and have done very, very, very well return on investment on the investments they've made in the cloud, they've really embraced this concept. It's a really core concept of compute, separating compute and store. So I won't belabor you guys on what that means, but ultimately being able to split, not being bound by hardware like in your on-prem environments, and really just focusing in on and I want my data lake to grow and infinitely, and I want to bring my compute services to the cloud itself. Cloud really helps enables that, and for customers that really embrace that, even though that's just a core concept, it's a very important concept. So something to keep in mind when you're starting to think about cloud. What does this mean for me? The next one here is moving away from multi-tenant architecture. So this is a concept for a lot of folks that started off on the on-prem Hadoop legacy, quote unquote, legacy big data infrastructures. And this idea of having multiple use cases on the infrastructure itself is very, very powerful because let's face it, setting up a Hadoop infrastructure on-prem is a pretty expensive endeavor, whether it be upfront hardware costs, having the cost to maintain, knowledgeable folks to make sure this stuff is up and running. And so it really made sense, and the industry really kind of pushed this whole multi-tenant architecture because, hey, let's maximize this huge investment that I have. Well, that has its challenges. So having multiple use cases on one infrastructure at the same time, you have resource contention, people not getting the resources, bad user experience, so on and so forth. And so folks that have the chance to re-architect to the cloud and start thinking, hey, instead of having one monolithic cluster, why don't I have my big data or my data scientists use a service that can just burst up, for however long they want to run their models, and then just and then be done with it. Whereas my batch ETL jobs continue running without impact with anybody other tenants. And so starting to really kind of think outside of this, hey, instead of this monolithic, I should really start, breaking off and using certain technologies based on what they're best at, really bring success for those cloud architectures. The next piece here is the elasticity that compute that the cloud brings. So kind of going back and forth about that whole on the on-prem side, you always have to create your resources so that way you have as much all the resources that you have, for throughout the year. And so for companies where they're maybe their traffic, maybe it's a retail company and it's the Christmas holiday season where they have so much more growth. If you're hosting all this on-prem, then you have to plan for the worst case scenario, right? So again, with the cloud, being able to just really pay for only what you need, spin things up to keep up with demand, spin it down when you're done, becomes very, very attractive. And so you want to start thinking about architecting your solutions that way based on whatever cloud vendor that you select. And then ultimately, whatever we do, this is a new technology stack. This provides great additional use cases, additional opportunities, additional ways that I can grow my product. If you're not thinking that way through and you're only thinking, hey, this is just more of a, I'm just doing the cloud because my other industry members are doing the same thing and not taking advantage of this, you're doing yourself a disservice. Like some specific examples of this would be, hey, IoT use cases, maybe more machine learning, deep learning kind of algorithms where you might have been hardware prohibitive to do this from within on-prem originally. take advantage of it. I mean, the cloud has opened up great opportunities. In fact, as you know, there's a lot of great technology out there that was born in the cloud just because what the cloud was enabling you. So as you guys go through and start thinking about, how I'm going to do my cloud, these are some good best practices to think about, because these are tenets of information that I see, very successful cloud deployments succeed. So everything's all good. When we talk about the do's, let's talk about the don'ts for a few minutes here. So on the flip side, I've seen lots of cloud customers move into the cloud and either get sticker shock. Folks are on the firing squad because they've got they're not delivering on performance. Worse yet, I can think of a number of customers that we're working with where their original cloud deployments just flat out didn't provide the ROI that they were expecting, and they went back on-prem. And so that's a costly mistake or costly decision to have. And so again, just kind of thinking holistically about the number of customers where I've seen them being not so successful is the first one here is just total miss on just migration efforts. And so thinking of if you're looking at your existing big data environments, your workloads that are that you're using on today, if you're not picking the right service, or you're not you don't realize all the connections that your existing workloads are running on, and you try to push this through, that the whole effort of migration starts really taking place. Was just working with a customer where they initially thought that their migration efforts were going to cost them upwards to about $1 million. But when all is said and done, without cost overruns, everything ran months longer than what was expected, ended up being about like an $8 million migration effort just on migration alone. And so, kind of put things, maybe your scale may or may not be at that, but if you're not leading with actual data points to get that, that is a huge point that, that really bites people if they don't put much time and effort into figuring that out. The next big one here is you've got all these possibilities in the cloud. You've got infrastructure, VMs, you've got cloud services, you've got native tech, you've got your Databricks, your Snowflakes, all excellent technology that's out there. But if you're coming in and you're just mimicking exactly what you have on-prem, that's, recipe for the most part, recipe for disaster. Now, with a little bit of a caveat there. I mean, I've seen customers mimic things just to get it in the cloud, and then they go ahead and they expand to whatever services they want. That's acceptable as well. But if you solely think, I'm just going to move everything to the cloud exactly how I have it on-prem, do the math. Usually more times than not, that's an even more expensive endeavor, even including data center costs, managing hardware. So, for folks that think that I just want to be in the cloud because everybody else is, and I'm just going to copy my architecture the same way, you should really rethink that and make sure that that is the best decision. Here's another big one: resource wastage going unchecked. What I mean by that is on the application itself, understanding, hey, did I size this accordingly? I don't, how many times does this fail and I have to rerun it? When you're doing this on your hardware that you've already bought, it's a sunk cost, not a big deal, right? Besides just time wasted. When you go into the cloud, you're paying for all that. Cloud vendors don't care if it fails. They don't care if you're over allocating your Spark job where it only needed half the resources, so you're doubling your VM cost. So they don't care about that. So having a plan of not just looking at things such as, hey, auto scaling is great, but like auto scaling doesn't know that you're over allocating your resources on your job. And so having a tool to kind of understand that, it becomes very important. That's even more important when it comes into the cloud because of that pay-as-you-go model. And finally, end user expectations are not met. So let's forget about the tech, forget about the services that you have, but there's an expectation. You're re-architecting your platform. So if your performance and reliability is not the same, or if not better, you're going to start losing end users, start using the platform. And then, inevitably, they may want to go back to that legacy system that you were trying to move off of because, that's where they're, that performance reliability is what they were expecting. So again, things to keep in mind. So walking you guys through a journey here. So now that you have an idea about the do's and don'ts, now let's get a little more specific into the cloud options. Now, I can spend an hour plus talking about this, but in the interest of time, I won't go through everything here. But I do have two scenarios for you guys. I've got a hybrid environment where it's more, you've got your on-prem and your cloud, and then you got cloud native as well. And so if you're a hybrid environment, what's going to be best? This solution for you is, hey, you already have something that's going on. You have a sunk cost on the hardware that you want to continue to realize, your investment on for a number of years. And so that's, that's a good, this would be a good solution for you. Another one would be, hey, you've got use cases that could take advantage of cloud native, maybe bursty type behavior, but, hey, your bread and butter is on-prem. And so why not use the best of both worlds, right? So that data scientist example that I was talking about, maybe they need, 200 nodes to run their, machine learning, their deep learning algorithms for just an hour every day, and then that's it. Well, it doesn't make sense for me to add more nodes on my existing cluster just for them. Why don't I just have them just run that in the cloud? So kind of best of both worlds. So having that option while keeping your main platform intact becomes very useful. And then this one, stringent data security requirements. So specifically talking about Cloudera Data Platform, very, very powerful tool. As you guys know, they've been in the market for some time now. They have a very, very strong hybrid story. In fact, it's the best story, in my opinion, that's out there. And so they have some robust industry standard tools that it's been in the market out for years. So think of like your Rangers, your Sentries, your Knox, et cetera, and so forth. And so if you already have that stuff baked in, or maybe you have very, very strict data security requirements, this could be something where you leverage, like Cloudera Data Platform, for example. Not to be a knock on the cloud vendors, but you can definitely lock down data, so on and so forth on their end. But in my opinion, CDP has a pretty strong offering on that. So if you want something to work out of the box, and you have very stringent data security requirements, it's something to think about with something like a CDP. When I say CDP, by the way, I mean Cloudera Data Platform. So benefits of this, less migration efforts, spending workloads to the cloud, we mentioned up before, the familiarity of the CDP in the cloud. Things to consider is, hey, doing this, now you've got you've got on-prem environments, you got the cloud environments. So, be cognizant of that. Another one too is just reliance. CDP is great, but you're still living in that platform itself. And so if you have ambitions of being, vendor agnostic, which is always a good best practice, that's something that you want to think about. All right, moving right along. So the next one here, cloud, multi-cloud. Hey, I'm coming in and maybe I'm just starting my big data journey. I don't have an on-prem footprint, which I'm assuming a lot of you folks on the call here may be in this bucket too. So hey, let's bypass that whole on-prem story. Let's go straight into the cloud. So this would be a great story for you. No requirements to keep data on-prem. I think that kind of goes, there's a number of companies that just started in the cloud, and so that makes sense to them. But hey, if you don't have regulatory reasons, security requirements, and you can just go into the cloud, hey, go for it. This is a good option for you. And then this goes without saying, hey, your use cases are cloud driven, right? If your use case is, hey, I only need to keep everything in one location and I have no requirements to have this anywhere else, and I don't have any elasticity issues, then this might not be the option for you. But for folks like that, this is a good option. Benefits, no upfront infrastructure cost. The bigger one for me, easy button. I don't have to have resources, at my beckoning call, very expensive resources. I don't have to buy, millions of dollars of hardware. I can just click a few buttons, upload maybe some configuration scripts, and then I'm off to the races. And then obviously never running out of resources, right? So because you are that pay-as-you-go model, you're only paying for what you need. Some things to think about though is you've got higher migration effort if you're migrating things. Here's a big one, understanding how the tech plays nice with other providers. You got to keep in mind that even though there is an industry push for any cloud, you're going to pay for that. It's in the vendor's best interest to keep you guys. So if you have a lot of requirements where you're moving in data, moving out, you got to be cognizant of that. A lot of providers out there wants you to load their data into their VPC or VNet. And so are you okay with that? Do I want maybe like my Databricks jobs reading off of my Snowflake, data source, cross-platform stuff like that. Things you really need to keep in mind, because each vendor has its own rules. And, as long as you know that, they prefer to have your data within their tools, you have to keep that in mind when you're thinking about your architecture. Pay-as-you-go model, I can kind of just go that real quickly. I mean, we talked being able to, you're paying for everything up in front. So just being cognizant of that, and then reducing the need for data movement between cloud providers. We touched base on that. So final statement here, guys. Now that we've kind of gone through the cloud journey here, hopefully, well, maybe not in this call, but in my presentation, you have an idea of where you want to go. And now what's the next step? That next step is being very prescriptive in your migration journey. And so where we see a lot of successful migration projects is that we break it down into three things. We've got, first of all, this just having a baseline. Hey, how are your resources are being used? I need to know, because again, that whole complexity, I don't want to have like a $7 million overrun on my migration costs. I want to know that all my data points are driven by data. And so this is where a tool like Unravel comes in. And so, one of the reports, the features that we have is being able to look at, your estate overall and give you that pieces of information. Hey, what are the type of applications I'm using in the cloud? What's my CPU memory consumption? Is this something that's bursty? Maybe I should move this to like a Amazon EMR or a Google Dataproc or Microsoft HD Insight and Autoscale. Like, you won't be able to make those data points unless if you have them. And so we have a tool, this opens up within minutes, and we can actually give you those information. So just being educated, again, always lead with the actual data points. Once you have that, now you got to start thinking about, okay, now there's a plethora of services. Now I got to start scenario basing here. And so we've got reports here that will look at, because we're monitoring your big data estate, whether that be on-prem or in the cloud, we can actually say, hey, if I'm going to pick, in this particular case, EMR, and I want it to be based on actual usage, right? Not based on what my hardware is today, what would that cost me? Or maybe I want to do this in maybe Databricks. Maybe I'm looking at my Spark. How much does that cost? How much does that compare? So on and so forth. Even more so, like, how are the data sources? What are the items that they select, or that the dependencies are on? So you need that information, and we are able to provide that for you. And then finally, once you're in the cloud, it doesn't stop there. So being able to understand and really start cross-referencing, hey, if EMR is my go-to environment there, and I need to start comparing between my regular Hive test job versus how it's running in EMR, this becomes very important for validating and managing and ensuring on that application level that you are getting that performance, and et cetera and so forth. And so with that, hopefully that gives you guys give you an idea. I've done this now again for a number of customers. This is something that I've seen very successful for folks that need to get into the cloud. So finally, key takeaways. I know I've went through a lot of information here, but just in my experience, and I'm trying to be agnostic as much as possible, guys. But some of the things that I've seen that I can leave you guys, so that ways you guys have tips to success for whatever your cloud journey takes you, is just anticipate that technology will change. Is Databricks going to be the de facto standard for Spark, moving forward? Science points that, yeah, that's maybe possible, but it might not be. Maybe there's another, Microsoft Synapse comes out and they have a better solution for your specific needs. So always gotta just know, especially in our industry, technology will change. Being able to architect your applications to be portable kind of goes through that same process. Make sure that, hey, this is my stack for this year. Is that going to be my stack for next year? Plan for that. I can't stress that enough. Leading cloud decisions based on data. So going back to my whole point, don't do this in a shot in the dark. Like, you're going to pay an arm and a leg, and your cloud initiatives could potentially fail if you're not leading with actual data points. The most data points that you can have to guide your decision is going to be most helpful. And then finally, hey, ensure your apps, wherever they may be, whether that be on-prem, whether that be hybrid, whether that be cloud native, ensure that they're running optimal. Best way to do that, use a big data application performance management tool like Unravel to ensure success every step of the way. With that, I'll leave it open for questions.
Awesome. Thank you so much, Chris.
No problem.
You do have time for one question. So
Sure.
from Greg Frere, are the spinning up and down cloud architectures as opposed to multi-tenant truly as simple as the claim suggests, or is there still an internal expertise required in advanced resource pooling, monitor, configuration, etc.?
Great question. I mean, we can really deep dive into that one. I'll keep it high level just for purposes of time, but it is simple. There's a bit of a DevOps component. I mean, there's a lot of tools out there like your Terraforms, like your Ansibles and so on and so forth. But to get that up and running means that you really truly are spinning up and down resources based on actual data usage, based on what your needs really are. And so, yes, 100%. I think that moving away from a monolithic architecture to maybe having 10 clusters, 15 clusters, whatever it may be, or maybe you do have some persistent clusters that stick up, a combination of the two. It's something definitely worth considering when you're really trying to plan out what that future architecture may be. Hopefully that answers your question.
Perfect. Well, thank you so much again, Chris, for being here and walking us through this. We're very excited to have you here and that you'll be joining us at the conference in September. Any questions
Awesome.
we didn't get to, we'll send to you after the webinar.
Perfect. Thanks, Kim. Thanks, thanks, guys, for having me.
All right. So next we will be hearing from Christopher Klaus from Talend. Hi, Chris.
Hi, how are you doing?
Good. How are you? Thank you so much for joining us.
Thank you for having me. So, yeah, thank you for this session today. We'll be talking about delivering data analytics fast with a cloud data warehouse. And my name's Chris Klaus. I'm a solution engineer. Been doing data science, data engineering for a couple decades. I'm a member of the technical team at Talend that works with customers to ensure we deliver technical solutions to solve business problems. I appreciate all of you taking time out of your day to listen to this session. And so Albert Einstein said a while back that the most important thing is not to stop questioning. That's especially true in the business world today. If we aren't asking questions, we're not challenging ourselves to do better, be more efficient, and to really understand the needs of our customers. The biggest barrier to answering questions directly is the ability to and accuracy of our data. This is where the speed and trust comes into play, which lies at the heart of everything we do at Talend. It's inherent in the value we try to bring to our partners. Today, we consider how our cloud data warehouse can provide us with answers to these questions and how the speed with which we can provide insight directly impacts the agility with which we can be responsive to customers' needs. And so I'll go ahead and introduce some concepts and then go ahead and go through our use case. The solution we're going to go ahead and develop, review the data I'm going to be working with, and then show a quick demo of Pipeline Designer to implement that solution. And then we'll wrap up and answer any questions. So let's turn our attention to working with this cloud data warehouse. And when we're looking at this modern cloud data warehouse architecture, most of the effort and focus, well, I shouldn't say most of effort, most of the focus is on the right side. In fact, let me turn off my camera so you can see that better. At least on my screen, I'm covering up part of this. So those targets, it's like your BI tools or what everyone's interested in, the analytics, the information they're wanting to garner off of the data. But a lot of their time is taking place in the data integration section. So to be a leader in today's competitive landscapes, businesses need to be data-driven. Data integration is fundamental to this and allows companies to operationalize data and make it ready for significant insights. According to Gartner, 60% of the time and cost is consumed by data integration. In fact, I've heard for data scientists, it can go up to 80%. That means that companies are spending most of their time collecting, governing, and transforming data, not analyzing it to drive the business forward. And that's where you're wanting to be. So now companies tend to focus a lot of the areas towards the right side of this slide on reporting and visualization. Having pretty graphs and reports is nice, but if you can't trust the data to drive them, it kind of defeats the purpose. As a data analyst or citizen integrator, improving your access to these data sets is a force multiplier, as the most positive outcomes come from providing dashboards, powering predictive models, or other types of data analytics. We can help you refocus that 60% of your time into productive work, creating these insights, as opposed to wrangling and munching that data. This process we will be working with today highlights the middle of this slide, where we will be taking data from a Kafka stream, transforming the data, and publishing it into a Grafana dashboard. We'll go into more detail on these technologies as we move forward here. So the use case we're going to be talking about, let's take a little closer in-depth look at that. Oh, and I skipped right over it. There we go. There's our use case. So I have my favorite company, Acme, and they have a data analyst at a web retail organization. And that company is completed their cloud data transformation, but they are struggling with accessing data in a timely fashion. The potential problems we're looking to solve are threefold. The website is frequently updated, and the content team is keen to determine how changes are performing in their A/B testing. The marketing team is launching a new campaign, which features an expensive spend using Google AdWords to drive engagement. In the dynamic world of web marketing, do you have the agility to react, tune the campaign, and maximize your investments in real time? So then finally, your security team is keen to be more responsive to availability issues. You have had problems with the website in the past, and from time to time, performance degrades. And there you have been even been having service availability issues. The objective is to ensure that your customer's experience is unaffected, your valuable brand is protected, and you uphold your service level agreements with your internal customers and partners. So having real-time dashboard to see that data and the accessibility of these pages is important. So the challenge here is how we transform the high volumes of captured data and present it in an easy to digest format to fulfill these reporting requirements. How can you, as a data analyst, not only build these reports, but access the data simply and easily to provide insights to your executive teams, rather than the current daily cadence? To go ahead and instead do real time, to really make it where it can become a decision driver for your business. So our solution. I'm delighted to tell you that Talend continued commitment to building out our cloud infrastructure means that we have tools specifically designed to tackle these kinds of problems. So we're going to look at Talend's Pipeline Designer. And here's what it looks like. And so we'll continue the data source Pipeline Designer. We will connect to the data source with Pipeline Designer. And it will automatically profile that data and create a schema for us. Once ingested, this certified data source can be reused by your team. The website activity data is logged and written to a Kafka queue, and Kafka is commonly used for website activity monitoring as it serves as a scalable, low latency alternative to traditional logging techniques with built-in fault tolerance and replication. To access this data, a user or client would subscribe to the topics within the Kafka cluster. The cluster manages the broker, which in turn deals with requests from clients. Data is written to cluster in key value pairs by producers and is then read by consumers. In this instance, the website log is written to the cluster by a producer, and our solution will act as a consumer, taking the data, aggregating it, processing it in a format suitable for analysis. So let's take a little bit closer look at what data we're going to be working with here. And let me jump forward here. And there we go. So we will connect to, yeah, we've already talked about that. There we go. The income data features these fields. It will have the IP address, date, time, method, which is get, put, post, resources or assets used by the requester. So what kind of computer OS they're using, things like that. HTTP status returned. It was a 200 to 400. Was there an error? The number of bytes returned, and then finally the agent or browser, which the device the request originated from. Fundamentally, it's fairly boring data, and it's not in a very good format to help us tell any stories. It's not great for BI work. We're going to go ahead and take this data, which is semi-structured at best, and work on transforming it so that we can really go ahead and use it for our story. We'll change the initial character string to a record format, then convert the data type so we can effectively aggregate the data. We'll group the data by resource, method, status, agent type, OS, and then select the maximum date, sum the total of visitors, and work out the average number of bytes transmitted. We'll then push this all to a MySQL database and then pull it into Grafana to go ahead and show it. Grafana is an open source observability platform or dashboarding tool. And it allows users to develop and share dashboards on an enterprise-wide scale. And so these dashboards will provide a visual representation of the stream data to allow a user to monitor, create alerts, and see metrics on a second-by-second basis. It serves as a perfect complement to the data stream from the Talend Pipeline Designer. So let's get right into, okay, there we go. And I did kind of talk through this. I forgot to skip a slide. Okay, so this is where I was talking about how I was extracting it, converting it, aggregating it, and then visualizing it. So now we'll get right into the demo. And I'm going to switch my screen share. And I'm going to share my browser here and switch right over to Pipeline Designer. So I've logged in, and I can see right here, I've got some pre-built targets and sources. So I've got an Elasticsearch, a Kafka queue, and a MySQL database sitting out here. But I'm going to show real quick how I could connect to a new system. So I could go ahead and say, I want to go ahead and connect to Kafka. And I'm going to give it Kafka Toronto Big Data. This is going to be the name of my connection here. I'm going to go ahead and have a remote engine sitting out there, which I'm going to run my pipeline on. And then what is the type of connection? Well, the Kafka connection. And then I need to grab real quick the location of my broker. My connection, make sure that it's working. And I can see that the test was successful. So then I can go on to add my data set. And I'll go ahead and give it a name. Log for the Toronto Big Data workshop we're doing here. And I'll look. I've already got my connection. I'm looking now for my topic, and there's my topic of my Apache logs. And it's a CSV format. And my delimiter, I'm going to use a special character of an X. I can validate that. And it's going to go ahead and bring up some visuals of, it's going to fetch a sample, it's going to profile that sample, and then go ahead and give me some information about it. Now, I can also go ahead, when I'm here, add some other information like who's going to go ahead and who created this, who's responsible for this data set. I can do some social aspects of this, of saying I like this data and things like that. But the main part that I'm getting here is I can easily pull this data in, and I get a quick profile of it that should pop up momentarily here. Now, it would do the same thing with my SQL to go ahead and have access to my target database. So we can see right here now, my profile of this has come through. So I connected, I created the data set, and now I want to go to my pipelines and create a pipeline. So I'd add a new pipeline. I'd go grab my source, and it's a log, and there's my Kafka log, right? I'd go ahead and say, well, maybe I want to grab from that every 5 seconds. Notice as I'm doing this, that I'm building out my pipeline, I'm seeing the input and output in real time of what's going on here. Maybe I want to go ahead and do some Python. Let me grab real quick some Python code to throw in here. Notice now that I've gotten much more structured data now that I've gone ahead and parsed it out with my Python. And I could continue on to add more components and build this out. In the interest of time, I'm going to go look at one that I've finished already that I have running here. So the next step is I went ahead and converted my bytes and my date time. So there I've got my date time format. And then I aggregated my data. So I grouped it by these different fields. I went ahead and looked for the maximum for the date. I looked for a count of the number of times an IP hit my website. So I get a visitor count. And then I did an average of the number of bytes they downloaded. So that gives me a little bit more better data. And after I did the aggregation, then I just added what my target was, landed it there. So this is running right now. And after I go to my Grafana, I can see my data has been flowing along, and I'm getting real-time responses here. Okay, let me go back to my screen here and go back to the slides. And get back to, oh, there we go. So to quickly recap, our data analyst has successfully socialized the website, logged data throughout the organization. So those different groups that we're interested in, whether it was marketing, wanting to go ahead and see that data to know if their Google Ads campaigns were working out well, or our security people to see if there were any attacks going on the website. It's like that dashboard allows real time to see these kind of things. Talend Pipeline Designer is a truly next generation cloud data integration environment. You saw how I was able to build quickly in minutes a flow of data and go ahead and wrangle that data up so I could then put it right out to my my Grafana, my BI tool, whatever that happens to be. You can deploy a pipeline seamlessly across batch and streaming use. So this is Apache Beam is what it's based on to go ahead and have these capabilities. Scale natively with the latest hybrid and multi-cloud technologies with a comprehensive set of connectivity options. And that we're focusing on the citizen integrator, the data analyst and data scientist, to speed up their time, that 60% we were talking about earlier, to go ahead and reduce that time so they can quickly get to doing the analytics. So Talend Pipeline Designer is a fundamental building block of Talend's data fabric, with more exciting features coming later this year. And let's see. So there's available a 14-day trial. I'd encourage you all to give that trial try as the next step. Our best way of understanding Talend data pipeline is to experience yourself. So yeah, that sign up will make it really easy to try it out. Also, I would encourage trying Talend Academy. There's trials of that available as well, so you can go ahead and get access to some of our free lesson plans. And talk about how the availability of data is impacting the departments within your organization, especially with our previous speaker, those explanations of the problems you may be facing. And this is a nice tool that fits into that kind of structure that Chris was talking about. Feel free to share this session with your team and reach out to us. And yeah, are there any questions?
Presentation. We do have a couple questions. Our question comes from Mohammed Khurshid Ali Khan. What are some of the frameworks for the data transform? Here, Here are you referring to Apache Spark and other similar frameworks Talend incorporates at the back end?
Yeah, so when I'm running on this remote engine, I can run on both a standard engine, which usually runs as a Java kind of framework, and alternatively, I can also run on Databricks, so I have more of a big data kind of environment. And as I mentioned earlier, this is Apache Beam is what it's built out on. So that gives you both the batch and real-time capabilities.
Awesome. Our second question comes from the same gentleman. Say we're using Spark for data processing, then do we enter the Spark code in the processor window?
So that processor, the processor windows, there was one for Python. So that's, he also mentioned Scala Python there. That's where you'd put your Python code. Now, Pipeline Designer is more focused on towards a data scientist kind of capability. So that's why we were focusing on Python with it. Talend Studio, one of our other tools, has more of a Spark and Scala capability. So while this does go ahead and run on Beam, if you wanted to go ahead and have components that were kicking off a Scala component that you've already written, it's like I would focus on that tool for those capabilities.
All right, terrific. Well, thank you so much again, Christopher, for joining us today. We really appreciate you taking the time. And we look forward to seeing Talend at the upcoming conference in September.
I look forward to it. Thank you.
Well, that's it for us today, guys, and thank you so much for attending another installment of the Big Data and AI webinar. We appreciate you tuning in with us today. And again, join us at the 5th Annual Big Data in Toronto Conference. The conference is taking place September 29th and 30th. Visit our website, bigdata-toronto.com, to learn more about the conference or to register. Thank you again.